Hello, guys. Welcome to another section of our studies on calculus. Today, we are particularly mastering the basic rules of differentiation. So, we've initially studied how to differentiate expressions or functions or quantities using the first principle differentiation. Now, what are the basic rules of differentiation? Now, let's understand the concept of differentiation by rule. That is an overview of differentiation by rule. You will start with the understanding of a quantity f, which changes with t, which is fundamentally differentiated using the first principle as we have the change in f divided by the change in t. That is df over dt equal to the limit as h approaches 0 of f of t plus h minus f of t divided by h. That is differentiation from the first principle, where this f of t plus h represent the new value and f of t represent the old value. So the numerator indicate the change in the value of quantity, and h represent the time interval from the new value to the old value. So as h approaches 0, the whole of this expression becomes the rate of change of quantity f with respect to quantity t. Now, for a daily use, first principles are time consuming for daily use. So we need to understand that if I want to find a differentiation of a function or a quantity with respect to another quantity daily, it becomes difficult if I am still using the first principle as a result of long expanded or tedious algebraic expression. So that is the reason why we need to stick to the differentiation rules. Now, differentiation rules allows us to find derivative quickly and effectively. So here, the basic rules of differentiation that we need to understand are: number one, we have the general power rule. The general power rule. Then the next one that we are going to study here is the constant rule. Then we also have to understand the constant multiple rule. Then we also have to get to know the sum and the difference rule. Then the derivative of the identity function. So here the differentiation rules are shortcuts. Simply, they are the shortcuts built from the first principles to help solve real world problems easily and faster. So these are the overview or the concept of differentiation rules. Now, let's look at the first rule, which is the power rule. The power rule is the general rule of differentiation. Now, let's see what the rule says. The rule says that if y is equal to x raised to the power n, where n is any real number, then dy over dx is equal to n times x raised to the power n minus 1. That is, the power n will multiply the whole of the expression x, and we also do subtract 1 from the exponent, which is n. So here, let's see an example. We have an example number 1. We want to differentiate y equal to x raised to the power 5. So when you compare this expression to the general format of the rule expression that we have here, you are going to realize that we have n to be 5. So using the rule which says that dy dx equal to n times x raised to the power n minus 1, it means that our dy dx will be 5 multiplying the expression, maintaining the x, and subtracting 1 from the index, which is 5. Now, when we do that, then our final expression will be dy dx equal to 5x raised to the power 4. So this represents the change in y with respect to x of this particular expression or function or relation. So here we can also work on example 2, which is about the root or fractional power. Now let's see, we are supposed to differentiate y equal to square root of x. Now, this expression can be rewrite as y equal to x raised to the power 1 over 2. Remember, square root represents an index fraction of 1 over 2. So if I want to differentiate, it will be dy over dx equal to the power multiplying the expression, that's 1 over 2 times x raised to the power 1 over 2 minus 1. And at the end of the expression, we are going to end up with dy over dx equal to 1 over 2 times x raised to the power negative 1 over 2, because when you subtract negative 1 from 1 over 2, your result will be negative 1 over 2. And this expression is an inverse expression, which can also be written as 1 divided by x raised to the power 1 over 2. So it means that when you write it in an inverse form, the negative will be out of the x as an index. So the expression will now be 1 times 1 divided by x raised to the power 1 over 2. Which we are going to end up with dy over dx equal to 1 divided by 2 square root of x, because 1 over 2 represents square root of x. So this expression becomes dy dx equal to 1 divided by 2 square root of x. So here, now let's proceed to example 3 for the power rule, that's the general rule. This time we are interested in the negative power. So we have to differentiate y equal to 1 divided by x with the power 3, which in indices can also be written as y equal to x with the power negative 3. So here we have dy divided by the dx being equal to, still using the principles of the power rule, we are going to have minus 3 times x with the power minus 3 minus 1, which will end us as dy over dx equal to minus 3x raised to the power minus 4. And this expression can also be written as minus 3 times 1 divided by x raised to the power 4, because we can rewrite this one in an inverse expression form, that in the fractional form of this nature. So here, when you simplify the expression, our dy over dx will be equal to minus 3 divided by x raised to the power 4. Now, let's look at the key insight of the power rule of differentiation. You can rewrite roots and fractions as power before applying the rules. Then, we need to understand these basic principles here. For example, if we have cubic root of x raised to the power 4, it can also be rewrite as x power 4 or 1 over 3, which will be simplified as x raised to the power 4 divided by 3. Then we can also get 1 divided by x with the power n, that is inverse expression and index form. It can also be written as x raised to the power minus n. So this completes the power rule. Now let's proceed to the next rule, which is the constant rule. Now the rule says that if y equal to c, where c is a constant number, then dy over dx is equal to 0. Now, why are we saying that? Here, a constant does not change as s changes, so its derivative is 0. So a constant is still a constant, it doesn't change. So it can also be written as cy equal to cs with the power 0, because any number power 0 is 1, still like we see. So if we apply the power rule, that's the general rule, then dy dx will be equal to 0 times cs 0 minus 1. And any number which multiplies 0 is the same as 0. So let's see an example here. If we have to differentiate y equal to 7, then dy over dx is equal to 0. So this is the constant rule. Now let's proceed to the next rule, which is the constant multiple rule. So the rule says that if y equal to k dot f of x, where k is a constant, then dy dx is equal to maintaining the constant and differentiating the function. So you have to differentiate the function, then multiply your results to the constant, which is k. So what it means is that the constant factor remains the same whilst you differentiate the rest of the expression or the function. So let's see an example here. If I want to differentiate the expression or the function y equal to 5x squared, then my dy dx will be equal to maintaining the constant, which is 5, and differentiating the expression, which is x squared. So when we do that, we are going to get 5 times 2x raised to the power 2 minus 1. That is how we differentiate x squared. That is 2x power 2 minus 1. When we do that, we are going to have 2x. Then 5 times 2x will give us dy dx equal to 10x. The next example is to differentiate y equal to minus 3x raised to the power 4. Then dy dx will be equal to maintaining the constant and differentiating the expression x raised to the power 4. So here we are going to get 4x power 3. And remember, minus 3 times 4x power 3 is equal to minus 12x power 3. So that is how we differentiate a constant multiplying a function. So now let's proceed to the sum and difference rule. The rule states that for a function f of x and g of x, if y equal to f of x plus g of x, then dy over dx is equal to differentiating the function f of x with respect to x plus differentiating the function g of x with respect to x. In the same way, if y equal to f of x minus g of x, then the rule is saying that dy over dx is equal to differentiating the function f of x minus differentiating the function g of x, all with respect to x. Now let's work an example. Here we have to differentiate y equal to x power 3 plus 2x squared. So if I want to find dy dx, then my dy dx is differentiating x power 3, which will be 3x squared, and differentiating 2x squared, which will be 4x, as dy dx equal to d, that is differentiation of the x cube plus differentiation of the 2x squared. And the end result will give us dy dx equal to 3x squared plus 4x. Now let's work on another example, and that will be to differentiate y equal to 4x power 5 minus 7x squared plus 3x plus 3. So here my dy dx will be equal to differentiating this function, which will give us 20x power 4, and differentiating this function, which will give us 4x, and differentiating this constant, which will be 0. Now let's proceed to example 3. Under the sum and difference rule, we have to differentiate the function y equal to 2 cubic root of x minus 3 divided by square root of x plus 7. This expression looks complex, but we can rewrite the expression as y equal to 2 x raised to the power 1 over 3 minus 3x raised to the power negative 1 over 2, because it's an inverse expression, plus 7. Then we are going to differentiate each of these functions or this expression separately. So the first expression, we are going to use the multiply constant rule. Second expression, we are going to use the same rule. Then the last expression, that's the last expression of the constant, which is 7, we are going to use the constant rule of differentiation. So here we are going to differentiate each term, which will be dy over dx equal to 2 times 1 over 3 x raised to the power minus 2 on 3. Maintain the constant, then differentiate the expression using the power rule. Minus, maintain the constant, which is minus 3, differentiate the expression using the power rule, plus differentiate the constant, which is 0. When you do that, your dy dx will be equal to 2 divided by 3, x raised to the power minus 2 on 3, plus 3 over 2, x raised to the power minus 3 over 2. And the whole of this expression can also be expanded in the form dy dx equal to 2 over 3 times 1 over x raised to the power 2 over 3. That is an inverse expression. And we repeat the same process for this expression too. That will be 3 on 2 times 1 divided by 3 power 3 on 2. Remember, 2 times 1 will give us 2. And 3 times this expression will be 3 bracket x squared. Then away from the bracket, the index expression will be 1 over 3. And plus, repeat the same expression to this, the same expression or the same format to this particular expression, which will be 3 divided by 2 bracket s raised to the power 3 index 1 over 2. Then the final expression will be dy dx equal to 2 divided by 3 cubic root of x squared plus 3 divided by 2 square root of x power 3. Now, the last rule, which is the identity function derivative, that is, it says that if y equal to x, then dy dx will be equal to 1, meaning that the slope of the graph of y equal to x is constant and equal to 1 everywhere. So here in real-life connection for this particular function, what we need to understand that in business, if sales increase exactly in proportion to marketing spend, then the growth rate is also constant. Then if a person walks 1 meter for every second that passes, their rate of change, which represents the speed, is also 1 meter per second. So if I have y equal to x, then dy over dx is also equal. Now let's proceed to practical scenario where we have to help a company to determine the cost changes as production increase, and that is the production expression where C represent the cost and X represent the shirt produced per day. So here we have Cx equal to 5x plus 10. So we are going to find the rate of change of the cost with respect to the number of shirts produced per day, that is the X. So dC over dx equal to 5, which means that for every additional shirt produced, the cost increased by 5 Ghana cedis. For every additional shirt produced, the cost increased by 5 Ghana cedis. That is a practical scenario of this particular studies. So let's look at the practical section here. We have to find the derivative of the following function. Try your hands on these particular examples and send your feedback to us. Then the next video will be for us to understand the advanced rules of differentiation, which is about the product rule, quotient rule, chain rule, and some practical application. And we are also going to extend the understanding on implicit differentiation and logarithm differentiation. Continue to follow this particular channel to receive the best of high school math education. Thank you.